Now let us start with the another chapter, that is strain energy and impact loading. Now here we are going to see the derivation of strain energy. Strain energy is nothing but the energy stored due to deformation. So here you can see this is a gradually applied load that we have shown. So it starts from 0 and increases up to value of P. And during that particular period, the deformation of the bar or deformation of the material is delta. So this is the load deformation diagram. So strain energy is nothing but the energy which is stored due to deformation under load, and therefore it is the form of potential energy. Now U is equal to area under load deformation diagram, and as you can see, as the load is applied gradually, if you drop a perpendicular from this, you will get a right angle triangle over here, and therefore area under this load deformation diagram will be equal to area of the triangle, that is 1/2 base into height. So this is 1/2, height is P, that is load, and deformation is the base, that is delta. So it is 1/2 P into delta. So height we have written first and base we have written afterwards. So U is equal to 1/2 P delta. That is our first equation. So this is the basic equation of strain energy. Now according to Hooke's law, delta L is equal to PL upon AE. So let us call this as our second equation. And also we know that stress is directly proportional to strain. So sigma is equal to constant of proportionality is capital E, that is modulus of elasticity, into E. Again, we know that sigma stress is equal to force upon area. So force will be equal to stress into area. So these are four equations which will be required for the further derivation. Now substitute the equations 2 and 4. So second equation is the equation of delta, and fourth equation is that of force, because P and delta are required for this equation 1. So these two equations we will be substituting in equation 1. So in place of P we are having sigma A, and in place of delta we are having PL upon AE. Now P upon A is nothing but stress. So 1/2 as it is, sigma A as it is, P upon A is sigma into L upon E. So this is sigma into sigma, that is sigma square upon 2E into A into L. Now this area into length is nothing but volume, and this particular strain energy you can express in terms of Newton mm. This value that originally you will get will be in Newton mm, divided by 1000, so that it will be in Newton meter or joule. So area into length is volume. So this is the another expression for strain energy. So in place of P we have substituted sigma A, and in place of delta it is PL upon A from these two equations, and we have obtained this expression for strain energy that is stored. For gradually applied load, the stress is given by, so there are three types of the load. So first one is the gradually applied load. Sigma is equal to force upon area. For suddenly applied load, if the load is applied suddenly on the bar, then it is 2 into P upon A. And for impact load means what? The load which is falling from a certain height, that is known as the impact load. We'll see the derivation for this impact load afterwards. So sigma max is equal to P upon A or W upon A plus P upon A square or W upon A square in the square root plus 2P HE upon AL or 2W HE upon AL. So these are the three types of the load, that is gradually applied load, suddenly applied load, and impact load. Now resilience or strain energy, it is the energy stored in a body within elastic limit, and it is denoted by U. So when the force is applied within the elastic limit, there will be deformation, and due to that particular deformation within elastic limit, whatever the energy that is stored, that is known as strain energy or resilience. Unit is Newton meter or joule or Newton mm. Proof resilience is the maximum strain energy which can be stored in a body within elastic limit, and it is denoted by U max. We have already derived the expression for strain energy, so it is sigma square upon 2E into volume. Again the units are same. Then modulus of resilience, it is defined as proof resilience per unit volume. So proof resilience is this particular one. If you divide per unit volume, means you have to divide this by volume. So volume will get cancelled. So ultimately it will be only sigma square upon 2e, and again it will have the same unit, that is it will have the unit Newton meter per meter cube, because resilience or strain energy will be having unit of Newton meter and per unit volume, so divided by meter cube. So it is joule per meter cube or Newton per meter cube. So the numerator is the strain energy that is stored, or resilience, proof resilience, and this is nothing but the volume, that is mm.